Let me just go through the things that what we covered till date. It was about word embedding. Word embedding is just a process through which we can convert the words into the numerical form. Now, after converting into numerical form like this, okay, here we converted the words into simple numerical form. And then from this numerical form, we are creating the vectors for each word. Okay, why it is important to convert the words into vector, so that we can let the machine learn about the words, right? Now these numbers are actually representing words. This is one word, this is second word, this is third word. So now machine can easily learn about each word. Now once it is converted, we have to see how a machine can learn from it, right? So if I want a machine to learn from it, we need to do a hands-on. So for the hands-on, what we will do today, we will define some text, okay, and we will assign the label to the text. Okay, for example, let's say I have a document. Okay, in that document I have two kinds of information. Okay, let's say I have a document over here. Let me just try to write it. I'll open up Paint. Okay, so let's say I have a document over here and I have two kinds of information in that document. One is there is a information about cricket, okay, and there is a information about chess. Okay, so there are some, text are there for the cricket, then there are some text are about the chess. Okay, what we want, that machine should learn from this text, and later on, whenever a text is given to the model, okay, whenever a text is given to the model, so model should recognize that whether the text belongs to cricket or the text belongs to chess. Okay, model should be capable of recognizing, like suppose I give the model that I want to play chess, or Viswanathan Anand is a very good chess player. So model should know that, okay, I'm talking about the chess, right? So this is a simple case study that we will try to do over here, right? So 50% of the thing already we did. Okay, up to here we have to do the same thing, right? After this, we have to just prepare a model. Okay, a machine, a kind of a neural network model, right? So let's try to work on it. See, if I need such kind of, application. So for that, first thing what we require, data. For any kind of machine learning, deep learning, neural network kind of application that we want to create, the first thing actually we require data. GPT is also trained on huge amount of text data. Okay, LLM, any LLM, GPT, Gemini, Llama, whatever, any LLM is trained on huge amount of text data. So let's define over here data. Okay, we'll just define our own data, right? So in this data, let's say text is equals to, we will define few texts over here. The first text I'm defining, let's say about the cricket, right? So let's say, here, just allow it for me. Okay. Here I'll define, I am playing good cricket. So it is what? This is a text about the cricket. Okay, let's define one more text. This time, let's define a text about a chess. He is playing chess. Okay, thereafter, let's say we'll define over here one more text, because I want to train it. So at least 6 or 7 texts I'll define. I like to watch cricket. Okay, thereafter, chess is a mind game. Okay, cricket is played outdoors. Okay, then chess pieces are interesting. Okay, thereafter we played cricket yesterday. Okay, he won the chess match. Okay, so these are some text I have used. Now, in this text, the first is about cricket, the second is about chess, then cricket, then chess, then cricket, then chess kind of thing. So it's like we will define over here labels, okay, that are called target. So let's say the cricket I want to label as 0, okay, and chess I want to label as 1. So it should be 0, 1, again 0, 1, okay, and again 0, and this is 1. This is our first lab exercise in which we will see how actually machine learns from the text. Okay, how actually a machine learns from the text, right? So here we have assigned label 0 to cricket and we have assigned label 1 to the chess. All right, done. Now, if I want to use it for the learning process that I want machines to learn from it, what should we do? Let's relate with what we did earlier, okay, so that we can better understand. So earlier what we did, I have to convert the text into numerical form. So to convert into numerical form, I need to first create the tokens. Tokens are what? Each individual words. All right. Tokens are just the each individual word. So this guy will take care of tokenization. Right. Next, what we did earlier. See, when the tokens will be created, each time it's not necessary that we have an equal length. Okay. Like over here, this guy is having how many words? 1, 2, 3. Okay, 5 words. This guy is having 4 words. This guy again have 5 words. So ultimately it will create a unstructured data. For some sentence we have 5 words, some sentence we have 3 words, 4 words, like that. So I want a structured data because machine always learns from the structured data, right? So to have the structured data, what we did here, we used padding. Okay, like here these are representing your actual sentence. The sentence is having 4 letters. The space which are where we don't have any words, they will assign 0, right? Because the longest sentence is of what? 7 words. All right. So for that, this guy will take care of the padding. So I'll just import it. This library will take care of what? Padding. All right. Next, I need word encoding, right? That is embedding, right? So for the embedding, we are using what? We are using Keras TensorFlow. This guy is taking care of embedding over. That means this guy is like, we are just giving the information to this particular library, and this library is giving me what? At the end, vectors. Okay, this library is giving me vectors, right? So just pick up this library, okay, and it will give me vectors. Okay, now when we get the vectors, actually it's a kind of a matrix that would be created, and to manage the matrix, okay, to process the matrix, we required one more library of Python, which is called NumPy. Okay, NumPy library is used to handle or process the matrix numerical, data. Numerical Python. The full form of NumPy is what? Numerical Python. So these are the 3 libraries we are importing that we had imported earlier as well. All right. Now, once we have these library, what we do first? Tokenization, right? So for the tokenization, just tokenize it. Tokenizer. How we tokenize it? Let's again get back to the previous class. Okay. So in the previous class, what we did here we tokenized. Okay, for the tokenization, we need to define an object of tokenizer library. This object will do the tokenization. Tokenization means what? Just access each word separately. So this guy will take care of tokenization. All right. Now, how it will tokenize? It will tokenize when we provide the text data to it. How are we giving the text data? We are giving the text data using fit on text. Okay, this is what we are doing. Okay, so when we do it, it will just convert each word, each sentence into individual words. Okay, and those words we can see like this: tokenizer, okay, dot word index. Okay, so what this guy did, You can see over here, our whole sentences are there. From those sentences, all the individual words picked up, all the unique words picked up, and they had been assigned a particular number, right? Now, using this number, what we did? Using this number, we created over here the sequence. Okay, sequence of number representing a particular sentence, sequence of number representing second sentence, sequence of number representing the third sentence. Right. So same thing we have to do. So let's pick this thing up. Okay, and here we will do what? Text to sequence. And I'm using what? Tokenizer. What is tokenizer? Tokenizer is the same object, okay, which knows about our text. This is the same object which knows about our text because we had used fit on text method. Using fit on text method, we had given the information about the text. This text is containing the values, this knows about the text as well as it knows about the numbers for each text, right? So now if I will call over here the sequences, right, I will get the sequence of numbers. Okay, but this sequence of number is what? Unstructured. Okay, where we have some sequence 5 numbers, some sequence 4 numbers, like that. So obviously without padding, it can't be done. Like we have to just do the padding so that it can be properly adjusted, right? That means all of them can have the equal value, isn't it? So what can we do? The maximum length is what? 5. Over here, the maximum, you can say, length is what? 5, right? So as we have a maximum length 5, so I can define maximum length is equals to 5. Okay, and thereafter we'll call pad sequences. What is pad sequences? Already we imported here. Check here. Okay, this particular class that we already imported from the Keras. Okay, TensorFlow Keras, which will take care of padding. So we can just feed the sequences over here and it will perform the padding. Now, when it is performing the padding, it is performing what? Pre-padding, right? So there are other factors that we can also define over here. If I want pre or post kind of thing. One more thing we can define: maximum length. So maximum length is equals to what? This is what we can define. It will not, it is not mandatory. There is no change, but yeah, this is a parameter that we can use in some case. Thereafter, we have over here padding. So by default, it is a pre-padding, but if I want post-padding, that also I can do. But most of the time, this is a post-padding now. But most of the time, we work on the pre-padding because pre-padding is more effective if we are working on a particular model for the text prediction. Okay, if I have to do the text prediction, that we will do also. So this is a padded sequences. All right. Done. So once we have a padded, that means now we have a data in the numerical form. Okay. And then we also have the labels, right? Here is our labels. We also have the labels and we also have the data. All right. Now we will try to kind of build a model. We'll try to do what? First, try to do the embedding, right? First, we have to do what? We have to do the embedding that we did here. That will convert the things into vectors. Okay, we have to do the embedding that will convert the text into vectors. This one. All right. So how to do embedding? Let's do it. So first, here now we had seen over here, we had used it for padding. We had used it for tokenization. This guy used for tokenization. This guy used for padding. Now this one is left. Okay, this one will be used to create your model. Okay, a model which can do embedding, a model which can be used for learning. Okay, this guy will be used to create your model. Okay, a model which can do embedding. Okay, and which can do what? learning. Okay, learning about your text. Embedding will be process where each word will be converted into a vector. Learning is something which will learn from this vector to predict something. Okay, learning is like learn from these vectors and the labels to predict something, right? So let's try to implement it. First, I have to define model is equals to what? Models. What is models? Models is a inbuilt, models is the inbuilt class of Keras, which is used to define your model, the neural network model. So here what are we defining? Models dot sequential. This will be used to define your model, which is a sequential model. And what this sequential model will do? This sequential model, so it is like define a model for neural network to learn from text. That's it. Okay. So what we have to do over here? See, first I need to convert these words into the vector. Okay. Each word we have to convert into vector. Now, what I told you, how words are converted into vector. See, here I had explained you. Had I explained this thing? It is not mentioned. No. Anyway, let me just try to explain once again. Okay, I already explained it, but this thing needs a multiple. Like it's difficult to, because you're learning from for the first time, and many of you may not have that expertise in machine learning. So I can understand. I may have to explain this. I should explain this once again. So here I have the words. Okay, let's say what are the words do we have? Let's say I am playing good cricket, right? So how this guy will be converted into vectors? What vectors? I am playing good cricket, right? So this guy will be 1, this is 2, this is 3, this is 4, this is 5. Already we did this thing. Already we did this thing. Now I have to convert these things into a vector. Okay, like 0.13, 0.15, 0.17, 0.19, like this. Okay, I have to convert it into a vector, right? So how this thing can be converted into a vector so that machine can learn better from the vectors. Okay, so how it can be converted into vectors? Let's try to understand. First step is like these guys will be converted into this kind of form. Why only 5? Because here I am considering 5 words. Okay, how many words I am considering? I am considering over here 5 words. That's why. Okay, I am considering 5 words. That's why 5. All right. So these guys are converted into the 1 and 0. This is called one-hot encoding. Now from this one-hot encoding, we will create a neural network. Okay. In this neural network, we can have 5 neurons. Okay. Now I have to define the size of output vector. So let's say size of output vector is 3. All right. Okay. Now what happened? These guys will be connected to this output neuron like this. All right. Now I have to convert I into a vector, right? So how are we representing I? We are representing I like this 1 0 0 0 something like this, right? So here 1 0 0 0 0. Okay. Now your algorithm, your Keras library will do what? Will assign some value to these neurons. Okay. So these weights. Okay. Like this. They had been assigned some values. Once they had been assigned some values, so based upon the neuron input, okay, based upon what? Neuron input, this guy will do what? 1 into 0.1, this will get a value 0.1. Okay, then same process will happen for others, like this guy. Okay, now over here also some value, because these are 0.2, 0.2 multiplied by 0 will remain 0, right? So it is like 1 into 0.1 plus 0 into 0.2 plus 0 into 0.1, all right, plus 0 into 0.3. Okay, so it's like all of them become zeros, only 0.1 will be there. Now here it's like something else, like 0.2, 0.3, 0.5, 0.6, 0.6, something. Okay, these are the random values. This random value actually defines so that each word can get the different vector. Okay, that are basically each word can get the different vector, and same word when appearing for the next time should get the same vector. So actually machine learns about these things so that it can give a particular vector to each of the word. Now based on it, again 0.2 will be the output. Okay, then what happened, this guy will be, sorry, this guy will be connected over here. Okay, again there will be some random value defined and it will learn. Okay, 0.3, 0.7, 0.8, 0.9, 0.5, like this. Okay, or let's say 7. So based on the 0.3, so I over here represented by what, 0.1, 0.2 and 0.3. All right, next comes what, I am. Okay, I am. So for I am, for the M input is what, 0, 1, 0, 0, 0. Right. Now this particular neuron is active. So for this neuron, the output for the first output neuron will be what? 0 point, you can see 2. Okay. Second output neuron is what? This is 0.3. Okay. And third output neuron is what? 0.7. Okay, so here the M. So I was represented by 0.1, 0.2 and 0.3. M will be represented by 0.2, 0.3 and 0.7. In this way, each word will get the different vector. This is called what? Word embedding. Each word is getting what? Different vectors. So the same process we have to do over here. We have to just create a layer into the model by using model.add layers.embedding. Okay, these all things will be done by the library itself. Okay, why library? Why can't we do on your own? Because it's a huge number of weights. We can't manage manually. If we try to manage it manually, it will be kind of a problem, right? Yeah, Gaurav, just allow me for a minute, right? Let me just finish it. This slide. Once I finish this slide, I'll take your query. All right. Now, here I have to pass 3 different parameters. One is called input dimension. Second, it is output dimension. Okay. And third parameter I have to give over here, input length. Okay. Input underscore length. Okay. So what is required? What is input dimension? Input dimension over here, if you see, what is input dimension? Input dimension is like how many number of unique words do we have? Okay, what is input dimension? How many number of unique words, right? So how many number of unique words do we have? We have the unique words that are over here. Okay, these are our unique words. All right. Now with these unique words, I have 24 unique words. So I can take the length of it. Okay, if I have 10, 24, here I have 5 unique words. So 5 unique words are converted into this form. So 5 input neurons. Here I have 24 unique words. So there will be 24 input neurons. So I have 24 unique words. And thereafter we have plus 1. Why 1? Because 0 is also there that we had added after padding. Okay, 0 we have added after padding. So this is what? This is your vocabulary size. This is the total number of vocabulary that we have. So we have 24 values. So that means I have to initially create the this particular vector will be size of 24. This vector will be size of what? 24, because in my document I have 24 words, right? So input dimension, I have to let this guy know that I am having 24 input words. Then output dimension, that I can choose as per our requirement. Like if I'm creating a larger model, I can, like suppose I'm working on very large amount of text data. I have suppose 10,000 words. So to represent 10,000 words, we need at least a vector size, output vector should be at least of 50. Okay, so that model can learn better. Here I have just 24, so it is we can just use anything like suppose 3 or 4 kind of thing. Okay, whatever the embedding size we require. Okay, let's say I want the embedding size over here. Embedding dimension. Let's say embedding dimension is 3, right? So this is what I can do, right? So embedding dimension over here. Okay, and last it is input length. What is input length? Input length is what is the maximum length of a particular sentence. So it is 5, right? So I can just define over here 5. Okay, so this is a process that we did in last class as well. If you check over here, okay, this is what we did. And after doing this, we did what? We just fit the data. After we did this thing, after doing this, here we did it. Just a minute, let me show you the program also. Yeah, so here we did this thing. Okay, after doing this, we fit the data. Okay, after doing this, we fit the data into the model. First, we define the model. We added a layer which is responsible for embedding. Then we fit the data, right? And the data is converted into vectors, right? So after this, here we will not fit the data directly, but we will build the neural network which will learn from this embedded vector, right? So this is a layer to create word embeddings, which are called word vectors. Okay, so this is something which will create the word vector, and this layer is responsible for that. Yeah, Gaurav, please. Thanks, Gaurav. Thanks for raising your hand. Okay, and please let me know if you have any question to ask.
Yeah. Hi, thanks. I have two questions. One, like we decide what will be the size of the output neuron, correct?
Correct, correct.
And on which basis is there any logic to decide? Like you said, for 1,000 we can use 50. We have a small data size, so we use 3 or 4. Any logic behind it, or is
Okay. See, when we define this output vector, there is no such mathematical formula through which we can calculate. It's just a kind of a that is called what this is known as. There is a term that we use. Trainable parameter. There is one. This one. Someone is joining. There is called trainable parameter, and there is called hyperparameter. All right. So this guy is actually a hyperparameter. Right, hyperparameter is something that we define. Okay, trainable parameter is something that machine learns. Okay, like these are what trainable parameter. These weights are what trainable parameter. That your algorithm will identify these trainable parameters on its own. But these are hyperparameters that we define. Right. So now, on what basis we define? See, first of all, it's just based on your experience. Okay, and second, when we define it, we build the model and then we check the model performance. If my model is underfit, okay, underfit means what? It is not giving the accuracy that we want, right? So it means what? It is learning lesser number of weights, and weights will be directly associated with how many neurons we are giving to it. Okay, if I give more neurons, it will learn more weights. If I give less neuron, it will learn less weight. So if it is underfit, we increase this thing. Okay, we increase, because after this, what happened? After we created this embedded vector, what we have to do next? Next, we have to create the neural network like this. Okay, these
Yeah.
are our embedded vector.
Well, you
These
are
are
showing
three.
something because
Yeah,
like no.
sorry.
Are you showing something?
Yeah, I'm showing something.
Means you are drawing something, yeah?
Yeah, I'm drawing. I'm drawing. My screen is not visible.
No, no, no.
Okay, why? Let me just
Only your
re.
screen is visible, but the annotation is not happening.
Just a minute. Let me just try to resave. Sometimes glitch happen.
So you can say the rule of thumb is if more number of
Now,
uh,
is it visible? Can you see my screen?
not yet.
Yes, sir. Yes, sir. It is visible.
You can see my screen. Gaurav, can you see my screen?
No. Anyone else? Please confirm.
Yes, yes, yes.
Okay.
It is visible.
Gaurav, can you just rephrase that rejoin? Just a minute. Let me just. Just a minute. Gaurav is still joining or what? Just 1 minute, okay? Okay, can you see my screen now?
Yes, sir.
Gaurav, can you see my screen? Gaurav, please confirm if you can see my screen or not. I can't hear you. Gaurav, can you see my screen?
I can see your screen now. Hi, sorry. Well, you are on mute, I guess.
Now you can see my screen, right?
Yes, yes. Thank you.
Okay.
Thank you.
Okay. So let's again rephrase your question. You asked me like on what basis we define. So here we define it based upon based upon two factors. First, on the size of data. Second, we just define any random number. Okay, based on our experience, based upon the kind of data we are using. Now, when we define any random number, there will be an output vector, obviously, right? Like this, there'll be output vector for each word, correct? Now, using this output vector, what we do, we go for the next step. In the next step, since we have an output vector of size 3, and I want my machine to learn for each word. Let's say my machine wants to learn about I. So I is represented over here by 0.1, 0.2, and 0.3. So this neuron will be given 0.1, 0.2, and 0.3. And after this neuron, there will be a hidden neuron, layer of hidden neuron, and there will be a layer of output neuron. Right? Now what happened? these guys will be connected like this. This input neuron will be connected to hidden neuron like this, right? All of them are connected over here, right? And now it will be connected like this. Okay. Okay.
So these hidden neurons, what purpose they serve?
Okay, I'll complete. I'll complete. Okay, you'll understand. Just a minute. Okay. So now it will be connected like this. All right. Now what happened? First, embedding is done. Embedding had given me the vectors for each word. Now those vectors we will feed into another neural network. In this neural network, we have 3 input neurons, and then we have some number of hidden neurons. How many hidden neurons? Again, it will be defined randomly based on the size of input neuron. Like suppose size of input neuron is 3, so here we define, like generally we define it in the multiple of 16, like 8, 16, 32 kind of thing. So now why this hidden neuron we define? We define the hidden neurons so that your model can learn about these input neurons and output. Okay, like I had given over here I, right? So if I want a machine to learn about I, so like suppose what I want my machine to learn about this complete sentence. Okay, so this complete sentence is representing what? This complete sentence is representing a sentence about cricket, right? This is having how many words? 1, 2, 3, 4, 5 words. Each word is represented by the vector of size 3, like 0 0.1, 0 0.2, what is it? 0 0.1, 0 0.2, 0 0.3. Each word is represented by a vector of size 3. Each word is represented by a vector of size what? 3, right? So it means total how many numbers will be there? 5 into 3, 15. 15, right? So here we will have 15 neurons. Okay, like this. Just a minute. 1, 2, 3, 4, like this. You can just consider it like this. Okay. So now these 15 neurons are all connected. Just a minute. So these 15 neurons are all connected to this hidden neurons. Like this.
Got it.
Okay. Like this, right? Over here. You can just assume like all of them are basically connected. All right, like this. All right. Now we have 15 neurons. So these 15 neurons are representing one complete sentence. Okay. This is representing what? One sentence. Okay. And the output will be representing what? 0. Output is what? Over here, my actual output is what? 0. Right. Now, based on the value that we give over here, each neuron will get certain value. Okay. That comes from the vector we have. Okay. Now these values will be, these values will get multiplied with these weights. Okay. Here there will be some weights. Okay. Some random weights will be there. Okay. Like suppose here weights 1, 2, 3 or something like this. So, it works simple like this. Suppose I have input value 3, 4, 7. Okay. And then I have a hidden neurons like this. And then I have output neuron. Okay. Let me just try to make it more simple. Let me just try to use only 2 hidden neurons so that it can be easy to understand. Okay, 2 hidden neurons, right? So here, like this, right, and then output. Now let's say here I have a value 1, here I have a value 2, here I have a value 7, here I have a value, let's say 2, here I have a value 3, here I have a value 4, like this, right? So this will be calculated using W0 plus W1 into X1 plus W2 into X2 plus W3 into X3. W0 value, let it be 1. W1, that is weight value, is what? 1 multiplied by 3 plus this is what? 2 multiplied by 4 plus 7 multiplied by 7. So here I got a value what? 49 plus 4 into 2, 8. 49 plus 8 will be 50, 57.
next neuron channels will also have some weightage, correct? Like this will get two values. ठीक है, got it.
Correct. Right. This one get a value 61. Same way, this will also get some numerical value. Let it be, you can calculate it like 2 3 into 2 6. 6 plus 7 into 4 28. So 6 plus 28 is 34, and this is 7 into 4 again 28. So again it would be 34 plus 28 will be what?
62.
62. Okay, let it be. Whatever, if it is incorrect, then it is correct. So now here there will be again some weight. Okay, let the weight over here 3 and 2. So 61 into 3 is what?
183.
61 into 3. Whatever, like whatever, like say x like 2 556 something you are getting anything. I just give the random value. So now here I got the value 256, but real value here, the actual level is what? Let it supposed to be 0. So it is expected that this value should be close to 0, but it is what? 256, right? So feed forward network, the feed forward process had given you some value. After we have some value here, there will be an error that will be calculated. What is error? Error is equal to 0 minus 256. That is equals to minus 256. So my error optimization process, that like gradient descent or Adam, again lot of error optimization processes are there. Those error optimization process will trigger the backward propagation. Backward propagation will tune these weight values. Okay, backward propagation will do what? Will tune these weights values step by step using a particular process, particular gradient descent process, so that these weights value can change in that direction in which this error can be minimized, right? So this process will go again and again so that this weight value can be optimized, can be tuned up to a certain extent so that this value can come as close as possible to expected value, right? And at the end, your model will learn about these weights that are called what? Trainable parameters. That means it will learn about these parameters. Okay, that's the purpose of these hidden neurons. If you increase the number of hidden neurons, what do you increase? You increase the number of weights, right? Isn't it? If you increase the number of hidden neurons, you are increasing the number of weights. Or if you are increasing this vector size, then also you will increase the number of weights, right? So when you are increasing the number of weights or decreasing the number of weights, there can be three situations possible. Situation one, if your number of weights are lesser than required, it will be an underfit model. Model accuracy will be poor. If your number of weights are more than it is required, right, it will be an overfit model. That means model learns a lot about the existing data, but not performing on a data which is not known. Overfit is like model learns everything. Like you have created so many weights that model learns everything about this data, right? You created so many weights that model learn everything about this data. But when anything outside this data we are giving, it is not performing well. So we have to avoid underfitting, and we also have to avoid overfitting. And for that, we require optimum number of weights. So how do we find out the optimum number of weights? Again, there is no mathematical formula for it. It is like we train, evaluate, tune, right? Or we use some other things like a dropout we use, in which we randomly say that, okay, in every iteration, just drop 30% of the weight, use only 70% of the weights. Okay, just to control that it should not get overfit and it should not get underfit. Okay, so that's how we define. That's why I said whenever we have a very large scale data, generally we define, we increase this thing. Okay, if I have suppose 10,000 or 1 million things, so we make this vector of size 50 or 100. Okay, generally we make a vector of size like a GPT. For the GPT, each word vector is of size 342. Okay, GPT had also used text to train the model. Now, when GPT had used text to train the model, they had created the vector of each word. The vector of each word they are using is of size 342. So 342 is, good enough, right? And then those 342 vectors of each word they are feeding into the neural network so that model learns about those words or sentences. All right. So here we did what we already created when we did this thing. Okay. This guy will create the vectors like this. Okay. Now this is representing your complete sentence. Okay. This is representing your complete sentence in which each word is represented by word. Each word is represented by a vector of size 4. Right. Each word is represented by a vector of size 4. Now these guys will be flattened. Flattened means what? It is 1, 2, 3, 4, 5, 6, 7. If I want my model to learn about this sentence, I want my model to learn about this sentence. So 4 into 7. 1, 2, 3, 4, 5, 6, 7. 7, that is 28. I will create a 28 neurons. Okay. If I want my model to learn about this sentence, I have to create what 28 neuron for the next step. The first step is done. Now we are moving to the next step. Right. So for the next step, what we do here, we will simply add one more layer. The responsibility of this layer is what? Is just to flatten the output. Okay. Just to flatten the output of previous layer. It will just flatten the output of previous level for each sentence. We have how many sentences? 8 sentences, right? So for each sentence, it will flatten the thing. So it will create the input layer. So now this thing is done. Flattening is done. Okay. Here we have flattening. Now I have to add hidden layer, right? So for adding the hidden layer, here we'll add one more thing, model dot add. Okay. Model dot add. Okay. Here it is layers dot dense. Okay. What I have to do, I have to just add over here 8, 16 kind of thing. Generally, if it is very small size model, 4 we can use. But there is no such rule. But most of the time I had seen people are using 8, 16, 32. Now I just try to find out the reason that why most of the time people are using 8, 16, 32, 32, 64, 128, 256, and so on. In the multiple of 16 basically. So I find a reason that our neuron system, that human neuron system, is actually arranged like that in a multiple of 16 neurons. So people try to replicate it. That's the reason. There is no mathematical reason I find out. This is something I find out. But there is no such rule. You can use 5, 10, 70, 20, 30. It's up to you. Okay. So here we are using 5 hidden neurons. And then we will add over here output neuron. Okay. So here, this is what? Flattening the embedded vectors to feed into neural networks. Okay. And here, what are you doing? Hidden layer with 5 neurons. Okay. And here it's an output layer with 1 neuron, as we need to predict 1 or 0. That's it. All right. Now here this model is done. Let me just try to check the summary. Vocab size is not defined. All right. Vocab size we have defined here. Why it is saying not defined? Okay. These guys should show me a number, but it's not showing me a number. Input length is depreciated. It is showing a warning and it is not showing a number. Mm, okay, no problem. It may be some library update maybe going on. It is not a big problem. It should show me actually the what number it should show. It should show me a number like this that it actually shows the number of weights. It shows the number of weights over here, right? But it's not showing. So I'll just cross check. I'll just cross check why it is not showing. But that will not affect the model performance. Okay, maybe some library update is going on. That's why. Now here we have to, once my model is done, we have to compile it. Okay, so compilation requires three things. Optimizer, that who will optimize the error. Okay, like I told you here, your input neuron value you are giving, you are given the input neuron value. Input neuron value is what? Is the vector, what vectors? Then we have a hidden neurons, then output neuron. Now here output will be calculated. Based on the calculations, this guy will calculate the output. Okay, this output will be compared with real output to find out error. Okay, and that error needs to be optimized. Optimized through what? Backward propagation. This error needs to be optimized through what? Backward propagation. Fair enough? Right. So who will optimize? So there are a lot of optimization algorithms are there. One of the very popular optimization algorithm called Adam. Okay. Adam is an optimization algorithm. If you see Adam optimization optimizer, right? So Adam optimizer sort of adaptive moment estimation, a popular efficient optimization algorithm used in machine learning, particularly in deep learning. Okay, it combines the advantage of two optimization technique, RMS, prop, and momentum, automatically adjust the learning rate for each parameter, making it adaptive. So now, do we need to go into depth of the Adam? You can go into the depth of the Adam if you are learning neural network in depth. Okay, for this particular course, you need not to go in depth of the Adam. If you are going through the course of deep learning, neural network, okay, so if you are ever going through the course, if you are trying to learn deep learning or neural network in detail, then you should go into the depth of it. Okay, for generative AI, it is not required. It is just you need to understand that how actually model learns from the text. So we just need to use it. Thereafter, we use the second parameter, which is called loss. Loss means what? How to calculate the error, right? Here, error is calculated. How it will be calculated? It will be calculated based on the output. What is output? Output will be either 0 or 1. Okay, output that we have defined is what? Either 0 or 1. So with respect to this output, I have to calculate the error, right? So that's why I have to use, whenever we have two outputs, this is a binary output. So we use the error cross entropy. That means calculate my error with using binary cross entropy formula, and then show me the accuracy. Okay, these three things we feed. Optimize using Adam. Let me write it over here. Optimize the error using Adam, right? Calculate the error using binary cross entropy. Okay, and then show the accuracy during learning process. Okay, so once we compile it, thereafter we use it to train, right? So let's try to use it to train. So for training, we have to use model.fit. We have to feed two things now. Train your neural network model. Train your neural network model to recognize a text is about cricket or about chess. That's it, right? So, okay, dot fit. So here what I have to do? I have to fit thing. What I have to fit? I have to fit the padded sequences. So when I fit this padded sequences, This guy will convert it into the vectors, word vectors. Those word vector will be flattened, will be given to the neural network, and then neural network will try to learn from it. So here we did it. Next, we feed over here labels. Labels are what? 1 or 0, right? And next we feed over here how many times I want to train. So I want to train it, let's say for 30 times. Okay. So if I want to train it for 30 times, so let's say what happened after 30 times, we get an error over here. Okay, fine. Unrecognized data type. When we are doing this thing, it is giving me an error that it is not recognizing this guy. Okay, so it is why it is not recognizing this guy. It should be recognized. Is it not? Just a minute. Let me check the type of it. Last time it worked, right? It's a numpy error, so it should work. Why it is saying that it is not recognizing? Something I'm doing incorrect. Just a minute, let me check. We had over here this padded sequence. In this padded sequence, we had given over here. So it should work, right? Why it is showing me an error? Padded sequences when I feed. Input length is fine, vocab size is fine. Unrecognized data type. Why it is saying me unrecognized data type? It should what happen. Flattening is already done, and dense is already used over here. Everything is good. Uh, this should work. Let me just try to check over here, explain error. This thing should work, or I may be doing some very small, because this is how we did it and it work. Okay, so what it is saying, the error occurs because the model accepts the label to be, oh, okay, fine. Understood. See what happened. I'll tell you. I'll tell you what happened. Actually, just let me just remove it. Okay. So what happened actually? See, it is something that we are giving for the input. Okay, to convert the text into vector and then use the vector for the training. Okay, what are we doing? This guy actually we are feeding over here to the model to convert it into vector, and then that vector we are using into neural network for the learning process, right? And we are using this label as a target column, right? That means I want my model to learn the data type of this guy, type of label. Okay, it is, see, this is numpy array and this guy is what? List. Okay, labels is what? Is a list over here. Okay, list is another data structure in Python. Okay, array and list is having slight differences. Array is basically homogeneous. Okay, like array can't have data of different types. All of them will be numerical, but list can have the string data, non-numerical data, any kind of data. So I have to convert this guy into numpy array. So labels is equals to np.array labels. Right. Only this line of code is required. So now it is converted into array. Right. So your input and output both should be what? Numpy array. Now it will work. Data cardinality is MB makes your all array contain the same number of sample. X size 8, size 6, Y size 6. Okay, so here I am feeding what? Okay, there is one more problem. We have 8 samples, right? But the labels that we have defined is only 6, right? So this one also I have to fix. Okay, so here it is cricket is 0 and this is what 1. Okay, label should also be 6, right? Because sample size is 6, sorry 8. So sample size is 8. So sample size is 8. So label should also be 8. Now everything is work. Now I expect it to work at least. So now it is working. Okay, but if you see over here, I am getting accuracy only 50%. Okay, which is obviously not a good accuracy. Now why are we getting? Let's say this is the input. This is representing my word vector. All right. This is representing my word vector. This is representing my hidden neurons. Fair enough. This is representing my output neuron. All right. Right. Now let's say this is connected over here like this. Right. This is connected over here like this. Okay, and this is connected over here like this. All right. Now here I have error, let's say 0.1, 0.2, and 0.3. Okay. Now we have some weights value. Okay, let's say weight value 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, 1. Okay, so let's say these are the weights values. Based on weights values, when we calculate the output, this particular neuron value, what will be the neuron value? This neuron value will be 1 into 0.1 plus 2 into 0.1, that is 0.2, okay, plus 0.3. Okay, I'm not considering weight, not let it be 0. Here it will be 0. 0 point what? 0.4 plus 0.2 plus 0.6. Here it will be what? 0.1 plus 0.8 plus 0.3. Just randomly I have defined any weights. So based on this, what will be the output? The output over here is 0.3, 0.6. Okay. Here it will be 1.2, 0.6, 1.2. Here it will be what? All right, 9, 10, 11, 1.2. Right. Now again, it will be connected over here. Okay. So let it be 10, 20, 10. 0 minus 48. Now your algorithm needs to tune this error. To tune this error, your algorithm needs to do what? Change these weights. Okay, it needs to change these weights in a direction in which your error can be minimum. Okay, your algorithm needs to change these weights in that direction in which your error can be minimum, isn't it? So it will change its weight, but the problem is here the linearity. Okay, we know that we have calculated the outcome over here as 48. These are the suppose value of input neurons. These are some weights came. Based on these weights, the value of these hidden neurons calculated. Based on the value of hidden neurons, the value of output neuron calculated, and we get 48 as output. Now I want that this value should be closer to 0. So error is calculated. Now these weights needs to be changed. Okay, I have to change these weights so that error can be minimized. But the problem is I have to reduce this it's very large weight, right? So we break the linearity. Why? Because if I don't break the linearity, this value can be anything. It can be 3,23395. It can be 72165. Okay, it can be minus 8,321. It can be anything. It can be, minus infinity to positive infinity. Right? This output neuron value can be from minus infinity to positive infinity. It can be anything. Right? And in that way, your algorithm, your process will become complicated. Your model can't learn these weights. Not possible to learn these weights. Because every time it is getting value in different, like sometimes it becomes very large, sometimes it becomes very small. Right? So as these output neurons value become very small and very large, so your model is unable to learn the proper weights. So we do what? We break the linearity. And for breaking the linearity, we use an activation function over here. And the activation function we use over here become 100%. So what magic it did actually, what sigmoid activation function did? Okay, Sigmoid activation function over here actually breaks the linearity. Okay, sigmoid function using this particular formula, right? Using this formula, where is the formula? Here is the formula. Okay. Using this formula, it breaks the linearity. So let's try to understand this formula. All right. So see what happened. I have a input neuron. I have a hidden neuron, right? Like this. Then I have a output neuron. The problem is linearity. Because of linearity, I am getting the value of output neuron from negative infinity to positive infinity. But it was either 0 or 1. But my real target was either 0 or 1. So it is getting difficult for the algorithm to optimize weights. So I am using this particular formula at the output layer. So what this formula is saying, see, output neuron value is calculated like this. Y hat is equal to W naught plus W1 into H1 plus W2 into epsilon 90. It will be positive. 8 epsilon 90, it will be positive. 8.19 into 10 to the power minus 40. Okay. If minus 9, then you can see it will be always positive, right? So exponential value over here, you know, just a minute. Exponential value, what happened? Okay. Fine. So the exponential value over here makes sure that your output will be positive. This output now can't be negative at any situation. Next modification we do what? We just write over here EY hat upon EY hat plus 1. This will be equals to EW naught plus W1X plus W2, sorry, W1, W1H1 plus W2H2 plus W3H3. You can just do that. W0 plus W1H1 plus W2H2 plus 1. So now it will make sure that output neuron value can't be more than 1. It can be 0 or it can be between 0 to 1. Why it will be between 0 to 1? Because you see what we did. We took the numerator, right? Added 1 to the numerator, right? So it means it is like this, 5 upon 5 plus 1. Can it be more than 1? At any situation, it can't be more than 1, right? So now this formula we can write like this: Z is equals to, okay, 1 upon, if you divide both numerator and denominator by the same value, let's say if I divide this numerator and denominator by the same value, W1 H1 plus W2 H2 E W0 plus W1 H1 plus W2 H2, right? So it will be what? 1 plus E. This will become 1, okay? And this will become 1 plus E negative of W0 plus W1 H1 plus W2 H2. Now this formula is used to calculate the value of output neuron, and the same formula that you can see here, okay? So this formula, when we use to calculate the, like, these will calculate the value of output neuron. Now that value, okay, whatever the value of output neuron we are getting, that value we will pass through this formula. This formula will generate the output in the range of 0 to 1. Okay, it means, let's say over here I'm getting an output as 0.85. Okay, my actual label is 0. Let's say the calculated value is equal to 0.85. The real label, let's say, 0. So error can be equals to what? 0 minus 0.85. Now this error, can be easily optimized. Okay, this error can be easily optimized, right? So, it just reduces the magnitude of error, as well as now the output neuron is getting limited between 0 to 1. So chances of, kind of random fluctuations also decrease. That's why my accuracy improved. That means now I have a model which is 100% accurate to identify a particular text. Is about cricket or is about chess. Okay. So let's say I'll write a text over here. New text is equals to today we have a cricket match. Right now it is like this thing needs to be kind of identified as 0. So how it can be identified as 0? First thing, I have to convert it into tokens, right? So how can you convert into tokens? So I can convert into tokens like this, or I have to convert into sequence. Actually, token is already there. I have to convert this thing into sequence of text. So I'll do what? Tokenizer dot text to sequence. Okay. Here I have to give what? New text. Okay. So when I give the new text, okay, this will be converted into numerical sequence, new text. All right. It is just converted into numerical sequence. Now, why only 4 words? Why only 4 numerical value? Because there are some words which are not there in the training, right? Like today. Today is a word that we have not used during the training. In the training, we don't have any word today. Do we have any word today? We don't have any word today. So that's why as today is a word which is out of vocabulary. That means we have a word today that we are using here that tokenizer don't know about it, because during the training today is not used. Have is a word is not used, right? That's why it just know about 4 words. Okay, because in training we have not used those words. That's why only these 4. Next, we have to do what? We have to perform the padding, so that we can give the same size of data that we had used for the training, right? So this thing we have to feed through pad sequences. Pad sequences is what we had used it earlier. Here, if you see, pad sequences doing what is basically converting all the things of size 5 so that it is a structure. So during the training, we had used a 5. That means for each sample, we have used 5 words. So we have to use 5 words. But here we have only 4 words. Okay, here we have what? Only 4 words. So I have to do padding over here. Okay, so in the padding, I have to tell this guy what I have to tell. I have to tell this guy that what should be the maximum length. Okay, that should be 5. Okay, that's why it added 0 over it. Also, and type also I can add. Let's say padding is equals to pre-padding. Okay, so now it is what pad sequences. Okay, so now I'll do what? I'll just try to model dot predict what the pad sequences. Okay, so when I do it, I get the outcome as 0.48, right? So now we will just compare this guy if it is more than 0.5 or not, because I get the output as between 0 to 1. If it is more than 0.5, okay, it will be what? It will be 1. If it is less than 0.5, it will be what? 0. Okay, so if I compare it more than 0.5, I'll get false. Okay, and then we will convert this thing into integer. Okay, so it is predicted as what? 0, and 0 we labeled what? Cricket. That means now I have a model which is recognizing the text related to cricket. Okay, let's define one more text. Okay, so I'll define one more text over here. This time I'll define let's say Viswanathan and Viswanathan Anand is a legendary chess player. All right, this is a text. Now I have to do what? I have to perform the this thing, that is this particular thing I have called. This guy will do what? Will convert into sequence and as well as pad it. And once we have the padded data, I can just use the model over here to predict. Okay. So now once it is predicted, we can compare if it is more than 0.5 or not. So it is more than 0.5, and then I can convert this thing into integer. Done. Right. So we have a model which is trained on the text data. Okay. And this model, this is our own model. Okay. Which we trained on our own text data. Okay. We are not using anyone else. We are not using GPT. We are not using anything. We have our own model which is learned using the text data that we have. And this model is good enough. Whenever we feed any text data to this guy is predicting a 0 or 1. 1 stands for chess, 0 stands for cricket, according to our own data. Right? That obviously we can write more if condition and all to give the output as a chess or cricket. But this is how, you know, the text data is used to train a model. Okay. In the upcoming class, we will go deeper into it. We will try to explore how a language model can predict the word. As of now, it is doing what? It is just predicting 0 or 1. Okay. How it can predict the word, next word in the sequence, that is word predictions and RNN and other things. And thereafter, we will move to using the APIs. Okay. API is a pre-built model like GPT, Gemini, Llama, right? How can we use the, because, you know, a small size model we can create, but it's not, you know, it's difficult to create a very large size model because model creation don't require only your coding skill. Large size model also requires high end system configurations. Okay, you require, you know, huge GPUs and so many things. So if I can't create a very large size model, so what I can do, I can use the large size model that is already there, right? So first we will work on RNN, thereafter we will work on GPT and other things. So that is the thing for the today. Please let me know if you have any query to ask from today's session. I know for some of you who are not so much aware with machine learning or deep learning, things may be complicated, but don't worry about it. It is just the process I am telling you. These things, why I am telling you, you know, if you're not getting it, if you're getting it only 20-30% of it, that is also more than enough. These things I'm telling you just to create a picture that how actually text gets processed. Okay, how actually text gets processed, how vector are basically used, how embeddings are actually used, so that when I will use these terms with the GPT, right, you should not get confused like, okay, what I'm talking about. Okay, so, you know, these terms, you know, when if you're going through these sessions, trust me, even if you're not so much aware with these things, don't worry, because these are not the part of generative AI. These are the part of deep learning. Okay, but I don't want to put you directly into that particular area, which in which everything will be a kind of will be just you know uh, irrelevant for you. So if you have these understanding, basic understanding also, then the, you know, journey that we are going to start in the field of generative AI and agentic AI will become very easy for you to work on it. Okay. See, as of now, what we did, if I have any text, okay, like text is like I like the movie. Now it's like I want to train a model which can identify this as a positive or negative sentiment. So what I have to do, I have to convert this thing into vector. This also will be converted into vector. Okay, this is what we did. Some numerical value will be there as a vector. Okay, like this. Okay, like this. This will be converted into vector, right? Okay, and this will also be converted into vector. Okay, something like this, right? Now these values will go to neural network. We have how many neurons? We have 12 neurons, right? So there will be a 12 neurons, 6, 7, 8, 9, 10, 11, 12, right? And these 12 neurons will get these values like 0.1, 0.2, 0.3 kind of thing. Okay, up to 0. Whatever 9, like this. Over here 0.9. There will be a hidden neurons. Okay. Now the how many hidden neurons will be used, that depends upon your model is getting overfit or underfit. Okay. If it is getting underfit, we increase the number of hidden neurons. If it is getting overfit, we decrease the number of hidden neurons. Okay. These hidden neurons helps my neural network to learn about these what weights. Okay. And thereafter there will be output neuron. All of them are connected. And this output neuron value is calculated as y hat. And then error is calculated as y minus y hat. Then error get optimized by tuning these values of weights. Your algorithm will tune the values of weight so that your error can minimize and your output can be as close as possible to real value. This is what we discussed. But what about if I want that my system should, my algorithm should not just learn weight, it should also have the memory. Okay. So now, so these guys are what, it's like we are feeding the text over here, but these guys are only learning the weights. That means it is not learning about that. Suppose I have a text over here. I like the movie. So this model is not having any information that what is present before the, okay, or what is present before like, okay, or what is present after like, okay, what is present after the, right? This particular model is not having that information. Okay, this model did what? Just learned about these weights. Okay, and once it learned about these weights, using those weights, it is further making the predictions, right? It is not having the information of the sequence. Okay, that is time stamp based learning is not happening. Okay, time stamp based learning means what? Actually, whenever you write any text, okay, you write a text like this. If this is your time t, this is your time t, then this is your time t minus 1. This is your time t minus 2. Okay, this is your time t plus 1, right? So this information is very important if I want to predict the next word. Okay, if I want to predict the next word, a model should have this kind of information. Okay, let's say next word, if this kind of information will be there, my model can easily predict the next word, like I like the movie watched. Okay, now this is a new word predicted. Now based on this word, okay, this whole information, it can predict the next word today, like this, right? So if my model is having the memory of what? Memory of past word. Okay, the sequence, the past sequence, it can easily predict the next word, right? And that is possible through a neural network which is called recurrent neural network. Okay, so what we build over here, what neural network that we build over here, this neural network is called deep neural network. Okay, we build the deep neural network. Okay, now we have to build what? Recurrent neural network. Recurrent neural network is dedicated for what? For the text. Okay, if I have to build a model which is learning from the sequence, it can be any sequence, it can be a text sequence, it can be audio sequence, it can be any kind of sequential data. Okay, if I want my model to learn from any kind of sequential data, then what we use recurrent neural network. Okay, the architecture of recurrent neural network works like this. There will be one set of neural network, there will be other set of neural network, then there will be other set of neural network, like this. Now let's say I have the sentence movie was good, right? So we feed the unit in this unit, that is unit 1. Okay, unit 1 we feed what? Movie. Okay. In unit 2 we feed what? Was. In unit 3 we feed what? Good. Unit 3 we feed what? Good. Right. So this unit is responsible to learn only about the movie. As of now, what we were doing, we were just feeding everything over here, right? That's why it is not learning about the sequence of the data. Okay, but we feed it like this. Now what we do, when we feed the information over here, this unit will learn something, and the output of this unit will be given to the next unit, like this. And output of this question is, I'm telling you this unit, but what present inside it? Okay, let's try to understand what will be there within this particular unit, isn't it? So you know how neural network, like suppose if I have a movie, so if I want my model to learn about movie, so first I have to convert movie into a vector, right? Let's say this is a movie which is converted into a vector like this, 0.1, 0.3, 0.7, okay, like this, okay, 0.1, 0.3 and 0.7. And there will be a hidden neuron like this, and their output neuron, right? This is what we do as per the current understanding, and then model will try to learn about these weights so that at the end it can, you know, kind of make some prediction out of movie, right? Now what we do, we will just turn this thing, whatever the structure that you see over here, okay, this structure we will just turn like this. This structure we will turn it like this, okay, and then we feed the here, so here we have to feed the information about the text. That's it. Okay, that means this whole structure we will turn it like this over here. Okay, it's very simple way to understand it, right? Here it will be like this. Okay, here it will be like this. Okay, so now we will feed one word to a single unit. This will just these particular weights will just try to understand about the movie, right? And then next we'll try to understand about was, then good. So in this way, when you prepare your neural network will have the weights, okay, to know about a particular word, as well as because of this kind of sequential architecture, it will also have the memory of word in with respect to timestamp. It knows that your model will at the end will knows that how the words are arranged, how the words are existing in the data. Okay, like after like deja was. Okay, so with the was, what kind of words are present? With the was, before was, what can be there? He can be there, right? He was, I was, she was. Okay, these kind of words will be there before was, right? So the model will learn about it, that was is a word, before was, these are the words which are having the highest probability, right? Same way after was, according to your data, whatever the things that, like suppose I'm using this data, let me show you a data also. Okay, let's say I'll show you a data. Okay, let's say, because I have to train a model on the text, so I require text data. So let's say this is my text data. So similar to it, I can use any text data. Now if I'm using such text data, model will know will learn that how the words are arranged according to a text data. After was there may be 2 words, 3 words, 5 words, or 7 words, or 100 words may have been used. Okay, but out of 1,000 words, out of 10,000 words, there may be 100 words may be there afterwards. Okay, afterwards, it's not like that all the word is possible afterwards. Okay, in your data afterwards, there may be 10, 20, 100 words may be there. So now model will have the memory that, okay, afterwards there are, what are the words that are having the highest probability, right? Like, afterwards it's like he was traveling. okay, singing, right, eating, like this, whatever, right? So, this architecture helps the model learn about the sequential information, okay? And if it learn about the sequential information, it can easily predict the next word in the sequence, right? It can easily predict what next word in the sequence. So overall, the architecture works like this, where here I will feed the input, okay, input 1 at time t1, okay, then input 2 at time t2, input 3 at time t3, okay, and then it will learn about the weights like this, and those weights it will just learn about over here, and here is the output, okay, output 1, output 2, right? That means the next neural network over here, okay, that is responsible for the was, okay, the next neural network over here that is responsible for what? Responsible to learn about was, okay, like this, okay, over here like this, right? So this neural network will also have the information about the previous word, okay, like the previous word we are feeding over, let's say movie, right? So this movie output, okay, whatever the output this guy is generating, so this output is what? This output depends upon all the weights that we have over here, right? That means ultimately this output, is having the information about all these weights, right? So this output will also go to this place, okay, and from here it will just attach it like this, attach it like this. So this is an additional weight that will be present, okay, this will be the additional weight that will be present, so that this neuron will also learn the weights along with the weights from the previous timestamp, and same process will go to the next unit, right? So this kind of neural network, when we create, we call it what? RNA neural network. What? Recurrent neural network, right? So recurrent neural network basically exists in 4 types, okay. The first type that we had already seen, first type is a simple one that we already created earlier, okay, that is the first type of recurrent neural network is what? 1 to 1, okay. This is the first type of neural network. 1 to 1 means what? Just like we created earlier, simple, we have one input and one output, just one input and one output, like we created earlier, okay. This is what we created here, okay. In this thing, last day that we created, that was if I'm talking about 1 to 1, so 1 to 1 is very similar to what we did here, okay. We are just feeding over here one input, okay, here it is okay, so we are just feeding over here one input, okay, and expecting just one output, that's it. That is what? 1 to 1, okay. So 1 to 1 is like simple one that we already worked upon. Thereafter we have 1 to many, okay. So 1 to many is something which is different. Here we have one input, okay, but the output can be many, okay. So where it can be used? It can be used in a kind of a information. Let's say I give the text data, and from the text data I want to identify the kind of some place, okay. Like I have an input data, from this input data I want to identify that in my text what are the popular, or you can say some places are mentioned like India, USA, okay. Or in my text, like say this particular output will recognize all the places, okay. Then important persons, important or popular person, like some prime minister or something like that, so this will identify important person, right? I want to identify from here, let's say important points, okay. Like for example, out of all the things that we are learning, okay, at the end we get the session summary, right? So in the session summary different outputs are there, Okay, we throughout the things we are giving the information, but at the end we get the session summary that is giving me that what actually happened in the last session. Okay, everything. So it's like one to many. We had given one set of data, and from set of data, many things being identified. Okay, like it identified that we had some audio issue earlier. Thereafter, we discussed one embedding. Thereafter, we discussed text classification. Thereafter, we discussed data preparation. Thereafter, we discussed neural network model. Right. So this is kind of a one to many. Or one more example. Let's say I have an image. Okay, and in that image, we can have kind of a multiple things may be there. Like suppose there is an image of traffic. Right. So image of traffic will have what? Image of traffic will have the image of bus, image of cars, image of traffic lights, right? Image of traffic lights, image of lane, image of kind of persons, right? So in a single image that we are feeding, there are multiple entities present. Okay. So this kind of model can recognize all the entities separately. Right. So this is called one to many. Right. Thereafter, many to one. Many to one is like we can create a neural network, a RNA neural network, in which we are feeding up many words. Okay, and then at the end I want the sentiment. Sentiment as positive or negative. I want the sentiment as positive or negative. That's it. That is many to one. Okay, that means the model that we created over here last day, the similar model we can create using RNN. Okay, here we created through deep neural network. Okay, this is working good because our text size was not that big. It was a very small text we use. Okay, but if I have a little bigger text, okay, little longer sentence, then we have to use RNN over here. Right. So RNN, similar things, similar kind of model we can create through RNN. Right. Next we have many. This is called many to one. Okay. Next we have what? Many to many. Okay. So where do we use many to many? Or many to one will also be used for text prediction or text generation. Right. Like for example, here I am feeding up the things like I like traveling. And I have to predict the next word. So next word, like I have given three words, three inputs. The next word can be like I like traveling more often. Okay, next word predicted can be what? Often. Right. So many to one can be used there also. Right. And last it is many to many. Okay. Many to many actually works like this. We have many input. Okay, and we will have many output as well. Okay, so this is used in what? In translation. Okay, this is used where? In translation, like English to Hindi translation or something like that. Okay, because we are feeding multiple words and all the words will be converted into other language. That is many to many. All right, so it depends what kind of application we have to create. One to one, one to many to many, or many to one. Here we will use many to one. Okay, for the next case study, we are going to use what? Many to one. Okay, we will build a model which will take our multiple text input and predict the next word, generate the next word. So it's like many to one. All right. So why RNN is required? Because RNN not just learn weights, it is also having the memory. Right? Why RNN is required? Because RNN not just learn weights. Weights helps a RNN to know about a particular word. Rather, it will also have the memory of the sequence. If we are feeding the sequential data, so that sequence, it will have the memory of that sequence, so that it can later on use to generate the next word. All right. So let's try to implement it. Okay, so to implement it, what we do, we will use over here, first of all, we should know how to read the text data. Okay, we can implement it, that's fine, but first thing we should know over here is how can we read the text data. So let's first read the text data. Okay. So let's say this is your text data that we may have to use. You can use any text data, right? So first I'll give this link to you. If you want to download it, you can download it from here. It's simple to download. Here is the download button, right? I'll download it. Download it. Now I'll go to my download folder. Okay, India_U. So I guess I have downloaded earlier as well. India. Okay, so this is text data that I have to use. If I have to use this text data, step one, I have to upload the text data into Colab. Okay, because I'm using Colab. If I'm not using Colab, if I'm using my offline tool, then I don't need to upload. Directly I can access from my system. But here we have to upload. Okay, so here we are uploading our text data, right? Once the text data is uploaded, what we do next? We will try to read this text data. Now, with this example, we will also learn about the Python file handling. Okay, so we'll open this thing. We'll just copy the path over here. Okay, open function basically used to open any particular file that we have in Python. Okay, so before any machine learning or deep learning model that can be trained on the text, the first thing we need to do what? The raw data must be loaded and processed. So we are loading up the raw data, right? Next, we have to feed over here read, right? So see, whenever we are working on the file handling, that means I want to read the file in Python. Okay, so we can do what? We can write a file. Just a minute. Okay. We can write a file. Okay, we can read a file. These two things we can do. Okay, so if I have to write a file here, I have to use W. But here file is already there. We don't have to write it. We are reading it. So we are using R. Okay. Now we will just store this thing into a variable called my text. Okay. So now if I will just print my text dot read, so it should show me the data, right? So that means I can successfully read the data into the Python environment. Okay, so if I can read it, what I can do, I can just store this thing into a variable that is my text. Okay, I just store it over here, right? And once I stored it, that means here, actually both sides we should not have the same variable. So better I should use over here my file. Okay, and here my file dot read. Okay, so now we can do what? Once I read the data, the process we should use what? We should close the file. Otherwise, you know, this will use extra resources, because once you read, you close the file. So this is how we close the file. Now if I will call my text, I can see my data file over here. So the data that I want to use for the training purpose, now I have that particular data. All right. Okay. So once we have the data, what we do next? I want to build a model which can learn about it. Right. So what we should do next? Next, we have to, just like previously we did, we have to do the tokenization. Okay. Always, this is one of the steps we have to do anyway. Okay. Always we have to do this tokenization. Okay. Here we are using it through program. Okay. Later on in agentic AI, we will use it with the help of some inbuilt tools. But we have to do it. Some way we have to do it, either by program or tools or anyway. Okay. Tokenization is something which is always we have to do, which will just access each word from the given text. Right. So how we perform the tokenization? We did it from TensorFlow dot text dot what? Keras dot preprocess TensorFlow dot Keras dot preprocessing dot text. This is what. So this is a library we are using it for the, I guess, third time. Right now, how tokenization this works? We have to define an object for it. Right. So my tokenizer. Okay. So this is the object. This will be equals to what? Tokenizer. Okay. Thereafter, my tokenizer dot fit on text. This is your function we are using or method we are using, right? And what is your text over here? My text. All right. Right. Now we can see what the once it is done, and I'll call what the dot word index, isn't it? Once it is done, fit on text, then dot word index, right? So I can call my tokenizer dot word underscore index. All right. So when we call it, I'll get each word will be assigned a, but each unique word will be assigned a particular numeric value. Right. So this one we can store into a variable called word underscore index. So this is an initial processing we have to do in each and every text data that I want to use for building up a model. Right. If I have to build a model, then this is what we have to use each and every time. All right. Okay. So you can consider it like this. This is one of the first step. Okay. Now we have to do what? We have to check how many total words are there. Okay. So how many total words are there? That would be length of word index. Okay. 598. We have total 598 unique words. Okay. In this text data, we have 598 what? Unique words. Right. Now, as we have a 598 unique words, then what we can do, we can just add 1 into it. Why? Because 0 is not there. And you know, when we do padding and all, okay, when we do padding, 0 will be added. So 0 should also be counted. So total number of words will be, okay, total number of words. Now, why we did +1? Okay, in case if you forgot it, please let me tell you. See, this is what we did, right? Here, to make it structured, we are adding 0. That is a padding, right? So this 0 should also be counted, right? That's why we are doing it. All right. So total number of words will be over here 599, right? So here, print vocabulary size. Okay, what is your vocabulary size over here? Total number of words. Okay, 599. Okay. Now, okay, one more thing. Let's say if I want to have, this is my text, right? Okay. So this is the my text, right? Now in this my text, you know, if I want to check any single line, how can I check a line? Okay, see, there is a split function of string. Okay, split. Okay, dot split. Okay, and here we give the reference for the splitting. So let's say I'm giving the reference for the splitting as a space. So when I had given the reference for the splitting as a space, what we got? We got all the words are separated over here. Okay, and we are getting the list of words. Okay, so instead of a space, if I will split based on new line, /n represents what? New line. Okay, so here we are splitting the text based on the new line. So these are the lines. Okay. Now why we did it? Because as I told you, we have to build a model which can predict the next word. Okay, like we are giving some 2 or 3 words. So using those 2 or 3 words, it should predict the next word, right? Like suppose I just had given the remark. Okay, I had given the model the word the remark. Okay, so my model should predict the next word will be may, then not, then be kind of thing. And in this way, it should complete the sentence, right? So that's why we are basically capturing each individual line one by one. Okay, each individual line we're just capturing one by one. Okay, like this. Here also we are capturing the individual line. Here also we're capturing the individual line. So it's like we're capturing each individual line one by one. That is very important. Okay, because what I told you, here the RNA will try to learn about the sequence, right? So it will learn about the sequence. So how it will learn about the sequence? If we have to feed you have to feed the sequence, right? So the sequence that we feed over here like this. So first we'll feed following, then we feed A, then we feed lavish, then we feed sentence, sorry, state, right? So to feed the sequential data, we need what? We need each sentence to be separated. Right, like first we feed all the sequence from the first sentence, okay, then we feed the sequence from the second sentence, okay, then we over here feed the sequence from the second sentence like this, then we feed the sentence from the sequence from the third sentence, okay, then we feed over here sequence from the third sentence like this, isn't it? So in this way we keep feeding the sequence one by one. All right, that's why we are doing it. Okay, so let's say here I have the lines. So I'll just store this thing into lines. Okay, and in case if I want the first 2 lines, so this is showing us the first 2 lines. Okay, this is the first line. Okay, and if I will go to the end, so this is second line, which is obviously blank. Okay, then we have a third line, we'll have some word, some sentence. Okay, first line, then after there is a blank. Okay, then there is a third line. All right. Okay, fine. So now we have to do what? We have to build a model which can predict the next word. So how do we build it? So we build it like this. See, if I am feeding the following, okay, so I expect my model to predict A. Okay, if I feed over here following A, so I expect my model to predict what? Lavish. Okay, if I feed over here following A, lavish, then I expect my model to predict state. Okay, if I feed over here following a lavish, state, okay, so I expect my model to predict visit, right? So in this way, this last column, okay, can act as a target variable. Okay, this will act as a target variable for my model. Okay, because a machine learning will learn from 2 things. One is called feature, another is called target or label. Okay, it learns from the 2 things. Machine learning learns from what? 2 things: features and labels. Like in the last example also, what we did, we were having over here features, and then for each feature we were having the label. Right. So machine learning model were trying to learn the relationship between this feature and the label. Okay. A machine learning model were trying to learn the best relationship between the feature and the label. Isn't it? So that's why here what we have to do, we have to create a target or a label, right? And this is a feature, but it is unstructured, no problem. We'll do the padding over here. Okay, so now my algorithm needs to learn about the information that we are giving over here, that is the feature and the label. What is the best relation between these things, and who will help it to learn? The RNA, that is recurrent neural network. Okay, and once it learn it, it can easily make the prediction of a word. So here what we feed? We feed the word vectors. Okay, here we have to feed the word vectors. And word vectors comes from what? Comes from the numerical value that we created. Okay, that means now we have to create a data like this, which can be used for learning. Okay, you have to create a data like this, which can be used for learning, right? So it should, be kind of a meaningful, So we will just we'll just create this thing for the first sentence, then we create it for the second sentence, then we create the same thing for the third sentence, then we create the same thing from the fourth sentence, right? That means I have to pick each sentence over here one by one. What we have to do? We have to pick first each sentence one by one. So for line in lines, print line. So it's like we're picking each sentence one by one. This is the first sentence, this is the second sentence, this is the third sentence, fourth sentence, fifth sentence, right? We are just picking each line over here one by one. Okay, right? Now each line information I have to convert into number. So who is converting into number? This guy is converting into number. My tokenizer dot fit on text. Okay, this guy had already converted into number. Now this numerical value I have to convert into sequence. So how can we convert into sequence? Yeah, see here. First, this guy did what? He identified the number for each word, or given the number to each word. This thing had given the number to each word, and thereafter one more function that is converting it into the sequence. So we'll take it tokenizer dot. Okay, let me comment this thing and paste it over here. Tokenizer, not tokenizer. This time it is what? My tokenizer. This time we are using what? My tokenizer. So here also my tokenizer. Okay. So my tokenizer dot text to sequences, and we feed over here what? The line. Okay. So let's do it. So my complete sequential data, which is a text converted into the numbers. From where this number is coming up? This number is coming up from here. Okay, so this my tokenizer is actually knows about the number of each word in the text. As it knows about the number of each word in the text, it is creating a sequence of numbers. All right, but the sequence of numbers, if you see present, how it is present, you can see this is one square bracket, then the second square bracket, right? So it is, if each line is there in two-dimensional form. Okay, it would be better if it would be in a single dimension. That means if it would be only this much, this external square bracket is not that much required. So what we can do, this external square bracket, and then we have anything, suppose over here like this. Okay, like this. 3, 2. If I want this value, so this is index 0. Okay, this is index 0. That means, see, this is the external square bracket, right? And this is enclosing this particular sequence of numbers. So let me go to the end. Okay, and here it is closed. Okay, so you can see the square bracket opened there, closed over there. So I want the info. That means this is an external square bracket. Within the external square bracket, we have only one list, and I want that list. So I can use what? Index 0. Okay, what I can do, I can just use over here index 0. Or I did index 0 at wrong place. Index 0 should be within print. Okay, so now we have what? just a single dimensional. This is representing first sentence, then there is a blank space, then second sentence, then blank space, then third sentence, blank space. All right. Okay. So this value we can store in a token list. Okay. Now what we do from here, now we have to do something which is a little interesting over here. I'll show you. Fine. So if you see here, we have a value 99, 4, 177. All these are representing words. So first we capture only 99 and 4. Okay. Next we capture over here. Okay, let me just do it like this. Okay. So first we capture over here only 99 and 4. Next we capture 99, 4 and 177. Next we capture 99, 4, 177, 50. Next we capture 99, 4, 177, 50 and 34. Okay. Next 99, 4, 177, 50, 34 and 28. Right. So that for each we will have the sample, and for each sample we will have the target node. Okay, like this. Just a minute. Okay, so now, okay, so these things will act as a feature, and this is the target. This is a feature, and this is a target. That means when I just feed 99, I want my model to learn that after 99, 4 is there. Okay, when I feed 99 and 4, I want my model to learn that after 99 and 4, 177 is there. Okay, so this is what we have to do. Okay, so how can we do it? Again, we'll get back here. Right here, what we did, we created a loop which is accessing each line one by one, because this is what, this is containing the complete lines. Okay, all the lines in the data. So using the loop, we are accessing each line one by one. Okay, and then we converted them into a sequence of number. Fair enough. Now what we do, from each line we capture 2 words, then 3 words, then 4 words, then 5 words, then 6 words, like that. Okay, so what do we do here? For token in token list, or just a minute, let me think of it. The logic is not like that. Actually, here we have to use range function. Now, if you are known to range function, it will be easier for me to tell. If you don't know, let me tell you. Here we will use a range function to run a loop. Okay. For loop, we did what? Here we did a for loop directly. Right. For loop we can create one more way, which is called range, or I in range. Okay. 0, 10. So the value of I will be what? Well, it starts from 0 and go to next 10 steps. This is your for loop in Python. Okay, the value of I starts from 0 and goes to 10. All right. So here we will use the same thing. I'll tell you why it will be used. For I in range, okay, 0, okay. What should I use here? 10, 20, 30, 40, 50 what? How many times I have to run the loop? Okay. See, if I have a sentence in which, let's say, I have only 10 words. Okay, let's say I have a sentence, and in that sentence I have 10 words: 99, 4, 177, 50, 34. Okay, let's say 5 words. Okay, so what I will do, I have to create like this: 99 and 4, 99, 4, 177, 99, 4, 177, 50, 99, 4, 177, 50, and 34. Right. So this is what I have to create. Okay, like this. Okay. So it's like, and then it is done. So now my model can easily learn from this data. If 99 is the input, then 4 is output. If 99, 4 is input, then 177 is output. Okay. So how many times loop is running? The loop is running for 4 times. Okay. What are we doing here? This is index 0, 1, 2, 3, 4. Okay. That means in the first loop, okay, in the first loop, we are capturing index 0 and 1. In the second loop, we are capturing index 0 and 1 and 2. Here we are capturing index 0, 1, 2, and 3. Okay. Here we are capturing 0, 1, 2, 3, and 4. Right? So we are starting from 1. That means we have to capture this thing first. So I can write a loop that will start from 1. Okay. I can write a loop that will start from 1, and I have total 5 words. So 1 to 5. Okay. So when I run it, 1, 2, 3, 4, I'm getting over here. What I'm getting for I in range 1 to 5 is 1, 2, 3, 4. The value of I starts from 1 and going for total 4 steps. Why 4 steps? Because 5 minus 1 is equals to what? 4. Right. Here 5 minus 1 is what? Is equals to 4. Right. So my value of I starts from 1 and go for 4 steps. So here, first I want the value up to index 1. This will control. Next, I want the value up to index 2. This will control. Next, I want the value up to index 3. This will control. Next, I want the value up to index 4. This will control. All right. So every time the number of values that we want, we are just changing over here. So it's like we are starting from index 1 and we have to run this loop that would be equals to number of value in a particular sentence. So that would be equals to length of token list. Okay. So the value of I will start from 1, okay, and goes up to the extent, that means how many values are there in a particular sentence. All right. And then what we do, we'll create over here print from that particular token list that we have. Token list is representing what? Token list is actually this is your token list. Okay, this is a token list of first sentence, this is a token list of second sentence, token list of third sentence, token list of fourth sentence. So we'll take the token list, okay, 0 colon index I. Okay, 0 colon index I. Okay, so let it be done. Okay, so here what we get, let's see. It is giving you the values like this. Okay, I'll explain it. Let me go to the first. Okay, so first it captured 99. Okay, why it captured 99? See, we were having the sequence like this: 99, 4, 177, 50, 34, like this. Now I said what? Run the loop for 1 to length of whatever the length of that particular sentence. Then we picked up the token list. Token list. Okay, given over a 0. 0 means what? The first 0 index colon the value of I. The value of I is what? 1. Okay. 0:1 means what? 0:0 plus number of steps. Number of steps. Okay. So that means it starts from 0 and take 1 step. So that's why 1 value. Okay. Next time the value of I will be what? 2. As the value of I will be 2, so it will be 0 plus 2. So it starts from 0 and take 2 steps. Okay. Then next time it will be value of I will be what? 3, because we are running a loop. That loop will increase the value of I. So take the 3 values. Right. So the process over here is like this. I should use I plus 1. Then only I can have this one first. Because if I will use this one, so there is no target over it, there is no label, it's just only one thing. What is it? There is nothing after it. So how anything can learn from it? Okay. For learning, at least we required a feature and a label. Right. That's why we are using I plus 1. That means I value will be 1, 1 plus 1, 2. Right. So take 2 value, first take 2 value, then take 3 value, then 4, 5. Right. So that is that. Okay. So we create a sequence of words over here. All right. Okay. Now the sequence of what is created, this one I can store into, let's say, take this thing, I commented it, and this one I can store into a particular variable called n-gram sequences. Okay. We just store into n-gram sequences. Okay, and this value we will store somewhere which is called a separate list. Okay, so let's say my input sequences is equals to a blank list, and in this blank list I have to store all these values, right? So my blank list dot append. Okay, what I have to append? I have to append this thing. Done. Okay. And then at the end, I'll print my input sequences. So my input sequences was blank. Initially, it was just blank. Nothing is there. But later on, we are appending everything over here. So it got everything stored over here. All right. Okay. So my data is prepared, not prepared, it is somewhat prepared, because now I have to do the padding, right? Because I have right now 99 and 4, okay, thereafter 99, 4 and 177, okay, thereafter 99, 4 and 177, and then 50, okay, then 99, 4, 177, 50, and then 34, okay. So we have this thing created. This is our label, okay, but features are what? Non-structured. So we have to do the padding over here. Then only it will be better. Okay. So padding depends upon what? Padding depends upon what is the maximum length of the sentence, which sentence is longest. Okay. If it is 5, then all of them should be 5. Okay. If it is 10, then all of should be 10. If it is 20, then all of them should be 20. So I have to find out which is longest over here. Okay. So what I do, I'll run a loop over here for sequences in my input sequences, access each sequence one by one. Okay, we are just accessing each sequence one by one. Print length of sequences. Print what? The length of sequences. So here we get the length of each sequences, right? Spelling is sequence, SEQUENC, right? So length of access each sequence one by one and print the length of each sequence. Right. So here, the first one is obviously 2, then 3, then 4, then 5 kind of thing. Right. So here we have each word. Here we have the things like this: 2, 3, 4, 5, 6, 7, like that. Okay. So if I have this thing, thereafter what we do? We can just store these values, these length into a particular list. I will give it a name sequence length. Leng, sequence length. Sequence length is blank. So this sequence length I will store over here. Dot append. Okay, dot append is something which will store these values. Now, if you know Python, it's good. If you not that much aware with the Python, let me tell you, list is a kind of a data structure in Python which stores multiple sequential value. Right. So here I have a blank list and I want to store all these information into that list. So first, length is calculated 2. So that 2, when we use append function, this 2 will stored over here. Thereafter, the next sequence length is calculated, which is 3. So 3 will be stored over here. The next sequence length will be calculated 4. So 4 will be stored over here. Next sequence length will be calculated 5. So 5 will be stored over here, like that. Right. So in this way, all the sequence length is stored. So if you see the first sentence having the 55 words, then again second sentence is started. So second sentence is having what? 40 words. Then third sentence is started. Right. So we are just storing everything over here. All right. So once these are stored, I'll just comment it. I will find out print sequence length. So sequence length we have is what? This one, like this. Now I'll find out the maximum of it. Okay. So maximum of the sequence length is 83. That means we have to do the padding so that all of them will become 83. Okay. All of, like, this is 2. So this should be of length 83. So we have to add 81 zeros before 99. All right. So let's import over here from TensorFlow dot Keras dot pre-processing import pad sequences. This is what we used last time as well. And we have to do what? In this pad sequences, we have to feed 3 parameters. Okay. What are those 3 parameters? The first parameter is what? If you see over here, we had used it. The first parameter is sequences. Okay. So sequences is what? My input sequences. Okay. Second parameter is maximum length, which is 83. Okay. And third is pre-padding or post-padding. Uh-oh. Something is incorrect. Huh? What is incorrect? If the import is failing due to missing package, you can from TensorFlow.Keras. Okay. One thing is missing. Dot sequences. Dot sequence. Okay. So done. Okay. So my text data is converted into numerical form when we are ready with it. And this we can name as input sequences. Input sequences. That's it. Okay. Now from this input sequence, I have to do what? I have to pick the last column as a target column. Okay. And rest all will be the feature column. All right. So that we can use it in the neural network later on. All right. So the last step that we have to do what? I have to define over here. Okay, we also need to import NumPy because we have to work on the matrix, and whenever I have to work on the matrix, okay, in Python we need to add a library called NumPy. So what is X over here? X is my feature, right? So what is feature? Everything, not the last column. I want everything, but I don't want the last column. See, if I want the last column, so I have to run over here input sequences, okay, comma, colon, and colon. Now, what is this? This process is called slicing your data. This process is called what? Slicing your data. Now I have to slice only the last column. So I'll use -1. -1 represents the last. Okay. Why I'm giving -1 over here? Why I'm not giving -1 here? Because if you have an array, then first before comma, that is used for row slicing. Okay. And after comma, that is used for column slicing. So I have to do this column slicing, right? I don't have to do the row slicing. Okay. I have to do what? I have to do column slicing. I need a last column. So it's like -1. Okay. So -1 colon. That means from -1, like say I've used -2 over here. So if I use -2, that means what? From the -2. Okay. This is what? -1. This is -1. This is -2. So from -2, I want everything. Okay. That's why -2 colon. All right. So -2 colon. That means from -2, I want what? Everything. Right. But I want last column, so -1 colon. So this will be considered as what? Your target column. Right. That is your Y. So Y we captured. Okay. Now X, what is X? X is like I want everything but not last column. Okay. So in that case, we can just use over here. Uh-oh. Wait a minute. Okay. In such case, we can use here what? I want everything but not want the last column. So here, let's say I'll use -1. So it is giving me just -1 I kept here. That means just before -1 I want everything. I don't want -1. That is last one I don't want. Right. So here it's like slicing we are doing. Like this. Okay. So I have X and Y defined properly. Okay. Now we have to use this information to train your model. But before we use this information, let me check the shape of it. So the shape of X is 1371 and shape of Y is what? 1371, obviously. All right. Okay. So here we just created our features and labels. Next, we have to do what? We have to just build a model which can predict the next word. All right. We are halfway done. Only we have halfway left. Okay. So let's build the model. So how do we build the model? Model is equals to, okay, for building of the model, what I told you last time. Last time I told you we need a library called from Keras dot from TensorFlow dot Keras import models. So this is what we'll import once again. Then we define model is equals to models dot sequential. That means I want to create a sequential model over here. This models dot sequential. Okay. And then we can do what? We can add the layer which will perform the embedding. Again, because we have to convert these numbers into word vector. So this is a layer we added, which is basically creating the embedding. So I'll just copy and paste it. Input dimension will be equals to what? Input dimension will be equals to total number of words that we are using. Okay, what is the total number of words? This is what we have. So this is a total number of words. Okay, that would be converted into output dimension that we can choose. Let's say output dimension, if I'm making it 16, that means each word will be defined by a vector of size 16. All right, like we did last time. Now input length will be equals to the maximum length that we have. Okay, what is the length of it? 82. Okay, 82, right? So it's like 82. All right. Now after this, what we did? After this, we created the deep neural network. But now you have to create RNN. So if I have to create RNN, again we can make use of the same Keras. Here we'll just add layers dot simple RNN. Just call it simple RNN. And this guy will create our RNN architecture that I told you over here. Okay, this architecture will be created. Now, how many units we require? As many words we have. We have maximum 82 words. So maximum 82 units. Okay. Now we have to create the output layer which can predict the word. Okay. So here we will use what? Model dot add layers dot dense. Okay, so if I have to predict one word, let it be 1. It is not correct, but still let it be. Later on I will explain you summary. Okay, this is not the exactly correct neural network we prepared, but yeah, there are few modifications we have to do. That modifications I'll let you know that what kind of modification required. But first, let's try to build this model so that we can understand the limitations of it. So next we have to compile. So for compilation, what I told you, what required? 3 things required. One is called optimizer, other is called loss, and third is called accuracy that we want to evaluate. Okay. All right. Now we will just fit the data. Model dot fit. What I have to fit? I have to fit x comma y, and I have to define epochs. How many times I want to train this simple RNN model? So epochs, let's say I will use 20. Or let's say 100. Okay, it will be 100. Let's see how much time it is taking. So now it will start the training. So accuracy is 4%, 1%, 6%, very poor. Okay, 6%, 4%. It's a very poor accuracy that we are getting. Okay. So we will see how can we fix it, but let it be done first. Okay, 29, 40. It is not improving. Like last time, my accuracy goes to what? 100%, but this time it is not improving. There is a reason behind it why it is not improving. It remained close to 5 to 6%, right? See what happened when we are using this model. Okay, what are we doing? We are feeding this data as an input data up to here. Okay, we are using this data as an input data up to here, up to this place. This is your feature. Okay, and this is your target. So target value is what, like 99, 4, 170. It can be anything. It is anything. Okay, it is not like last time 0 or 1. Okay, last time it was just 0 or 1. As it was 0 or 1, so what we did last time, we had used the activation function called sigmoid, right? So sigmoid was doing what? Was actually converting the last neuron value, okay, in the range of 0 to 1. This sigmoid was converting the last neuron value in the range of 0 to 1. Okay, the formula that I explained. Okay, and that's why error optimization were easier. Okay, model can optimize the error more easily. But here it is not like that. Here we can't use sigmoid. Okay, here we can't use sigmoid because the output is not 0 to 1. It is anything. But if I can't use sigmoid and it is expected to learn the next value, but it is not learning. It is not learning at all, right? So shall we increase the number of, number of this thing, that is word vector? Because if I'll increase the word vector, I'll increase the weights. No, because accuracy is very poor. Okay, somehow if you increase, you can make it 10%, right? Accuracy is very poor. So what do? We will go for the another approach. What is another approach? The approach is we have to do something so that output neuron value can be 0 or 1. Okay, that means I have to convert this thing, which thing? The target column. Okay, the target column. This target column somehow I have to convert it into 0 or 1. So how it can be converted into 0 or 1? Let's see. If I have a number like this, 1, 2, 3, 4, 5, 6, okay, I can represent this guy like this. This is what I told you. This is called what? One-hot encoding. We already did it because to convert a word into a vector, this is your first thing happen. Okay, this is your first thing happen which converts the word into a vector. Right, now we will use the same thing for my target column. Okay, what we do, we will use the same thing for my target column. That means I will implement the one-hot encoding for the target column. All right, let's see. Here we will import a library from keras.utils. We already used this library earlier. Import to categorical. Okay. Now we will use to categorical. Right. So what is YT? See, if I will call YT over here, the YT is, let's take the any single sample of YT. So this is a single sample of YT in which only one value is 1. That is the first sample. Okay, this is the first sample of YT in which only one value is 1, rest all are 0. Okay, right. So now why we did it? Because now we will try to build, the neural network model will work like this. Okay. See, after any particular word, let's say after following, okay, after following, how many words are possible? We have 590 words in the data. How many words are there in the data? We have five. How many words are there? Let's check. We have five. Oh, where it is? I can't find it out. Total number of words. 599. Okay. We have five. One is added. That okay, fine. So we have 599 words are possible after following. 599 words. Okay. Now, as 599 words are there, we have converted any single word. Let's say word 3. Okay. This is converted like this 0, 1, 2, 3. And then we have 0, 0, 0, 0, 0, 0. Total 599. Okay. Sorry, some connection, some network issues are there. Okay, fine. So, after the following, there are 599 words are possible. So we create the neuron of each word for each possible word. Okay. We create the neuron for each possible word. That is 599 possible words. So 599 output neurons. How many output neurons? 599 output neurons we will create. All right. So now if there is a word like, 3. So for 3, that model needs to learn how to predict 3. So model, if needs to learn how to predict 3, so model will try to learn to maximize this particular neuron value. Because this neuron value needs to be 1 if 3 to be predicted. If 3 to be predicted, then this neuron value should be maximum and other neuron value should be lesser, because this neuron value should be closer to 1. Another neuron value should be closer to 0. Okay. Same way, if a model needs to predict, okay, if for a particular sequence of data, if it needs to predict the next word as 7, okay, if it needs to predict the next word as 7, then it will try to maximize 0, 1, 2, 3, 4, 5, 6. It needs to maximize this particular neuron value, right? That's why we did over here one-hot encoding, okay, so that we can create over here. So, we can create the number of output neurons equals to number of possible words. Okay. So now if I'll check the shape of YT, that is 599. That means the output neuron value over here, again, the output neuron value that will be present over here will be equals to 599. Okay. And now out of all the possible neurons, there will be one neuron which will maximize and will go close to 1. So here also I have to use the function called activation function called sigmoid. Okay, just like yesterday. So now if I will build it and will try to train it, now I have to use YT over here. Okay. So something is incorrect. Let me just run on. Okay. So now I did this thing. Is it accuracy better? Still it is 7%. It should improve. It's not improving. Let me try with, since it is multiple categories are there. So let me try with categorical cross entropy. This is what that when we have just two category, then we use binary cross entropy. But if I have multiple category, we can use categorical cross entropy. So almost it is done. Only we have to build, we have to see how can we predict the next word. But for this, that whole process, first it should have accuracy at least 90% or something, but it's not improving. As it is not improving, I'll stop it.
interrupt the execution, and after interrupting the execution, I'll again execute it with categorical cross entropy. Any other change I should do? I don't think I should do any other change over here. There is one more change I have to do, but for doing that change, I have to explain something. As of now, let it be like this. Let me check with categorical cross entropy. No, it's not going good. Right. So this accuracy, we will take this accuracy to up to, okay, now it is improving. Yeah, good. I thought it will not improve. Now it is improving. Right. So now it goes to 23%. Now it will go to 90%, close to 90%. Easily it will go to 90%. Okay. So my model is now created, having a good accuracy. Only we have to check how these guys can be used for the to generate the next word or predict the next word. So here, first my file is accessible, then tokenization. Then we created the input sequence, and with the help of input sequence, we defined what output sequence as well. First word, the like first two word, then three word, then four word. The last column becomes target column. We made the last column as a target column. Then we just did the one hot encoding. One hot encoding one on the last column, the last value in the last column, right? So once we did the one hot encoding, so that if I have to predict 599, like I have to predict one word, but like suppose if I write anything over here, okay, let's say, just a minute. Okay, so let's say if I write over here anything like Indian, right? So after Indian, there are 599 words are possible, right? So that's why we did what? We just created a one hot encoding over here for each word, right? So that at the output we can use 599 neuron, right? And then machine will try to learn about like will try to learn to identify a neuron or to maximize the value of neuron whose probability is maximum. Okay, and each neuron is associated with a word. So whichever neuron is identified with a maximum value, that would be the predicted word. Right. So here training is going on almost to be build a model using RNN, and it is doing good. Okay. Now, meanwhile, it is doing, let's say I have an input text over here as India, right? So I have to predict few number of words after it. Okay. Let's say I have to predict after this 7 words. Okay. So I'll just write it over here, predict next words. That means I have to predict what 7 word. Now 7 word will not get predicted or will not get identified in one go. It will be predicted one by one. Okay, like if I'll write India, right? So after India, the next word may be identified or predicted. Okay, India, right? Next word can be like say is, right? So after India is using these two things, the next word will be predicted. Then using these three, next word will be predicted. Then using these four, next word will be predicted. So this process will go again and again. And this is how things done. GPT also works in a similar way. Okay, it just predict one by one word, and that's how the complete sentence get created, right? So that means I have to run a loop. Okay, so for let's say k in range, let's say I want 7 words. So for k in range 7. Okay, so this will just help me running a loop which can predict the next 7 words. All right. So how can we predict the next 7 words? First of all, whatever the word we have, okay, because training is done on the numerical value, right? So first step is whatever the word we have, this thing needs to be converted into numerical value. Okay, so how it can be converted into numerical value? It's simple. First, text to sequence. Okay, here the function that we used is what? Tokenizer dot text to sequence, where we used it here. Okay, so this is what we do. This guy will convert it into the each word will be converted into numerical form, right? So this is what we'll do. Tokenizer dot this one. So if I'll only print it, let me just print it to show you. Okay, what I have to feed over here, I have to feed the input text. So when I feed the input text, it is just giving 6. Why it is giving me 6? Because 6 is a number representing India in this particular document. Okay, the document that we have used, in that document 6 is that number which is representing India. Now why it is printing 6 for 7 times? Because my loop is running for 7 times, right? Okay, now once it is done, that means this value I will store into a particular variable. Let me comment it. I'll define a particular variable that is called token underscore list, and this will be this one. So it will be stored in this variable. Okay, next is what? I have to make a prediction after this word. Okay, I have to make the prediction after this word. If I have to make the prediction after this word, what I need to give this thing into the model. Okay, because model will predict the next word, right? But model was trained on what? Model was trained on a data in which how many features were, like, see, model was trained on X, right? So what is the shape of X? This model was trained on X. So what is the shape of X over here? The shape of X is 82. That means 82 features we are giving. Okay. That means I have to add 81 zeros over here. Then the length will becomes, suitable or compatible for the model, because model can't accept your one value. Model is trained on, for each sample we had given 82 numeric value. Okay, we had given a vector, and that vector is having what? 82 kind of, for each particular word is like each sequence is represented by 82 numbers, right? So if it is not 82, then zeros are there. We did padding, right? So over here also I have to do padding so that the length can be 82, right? So here I have to call pad underscore sequences. Okay, and for the padding, what I have to feed? First I have to feed the token list. Okay, so once I feed the token list, what will happen? It will ask me the maximum length. Okay, so what is maximum length over here? Maximum length is equals to 82, because 82 words, 82 is the length that we use for the training. Okay, and thereafter I have to do what? Padding. So padding is equals to pre-padding. All right, so let's print it and check what this guy actually did. Nice. So this guy had added a kind of a 000 to each to make it 82. All right. Okay. So now this information is required for what? For the prediction. So let's update this thing, make it token list. So my token list is now again updated. Okay. Next, I have to predict. So for predicting, what we do? We'll use model.predict. Okay, because model is trained already. Okay, here is a model we have which is trained. Right, here is model which is trained, right? So I'll just call over here model dot predict. Okay, after the training, it can easily predict. Okay, so for the prediction, I have to feed this thing, that is your token list. Okay, so if I predict it, let me just predict this guy. So let's see what are we getting, what sort of prediction is it. Okay, so if you see over here, we have total 6 predictions will be there. Okay, see, I'll show you. This is the first one, because, sorry, 7, because loop is running for 7 times. Okay, so this is your first predictions. Okay, and when this guy will end, as I scroll down here, from here I have a second prediction. Okay, then when I scroll down, okay, then third prediction. Then when I scroll down, okay, then fourth, okay, then over here, fifth, okay, then as I scroll down, sixth, then as I scroll down, seventh, right? So what is it? What are these numbers? Okay, these are actually the value of neurons. Okay, how many output neurons are we using? We are using 599 output neurons. Okay, whichever word is having the is predicted. Okay, whichever word is getting predicted, the value of that output neuron is maximum. Okay, that is close to 1, right? Whichever word is predicted, because there are 599 possible words, the probability. So how can we find out which word is having the highest probability? We can find out which word is having highest probability by using over here np.arg max. That means which particular position is having the maximum value. So we find over here its position 146. That means the word which it is predicting is having a number 146. Okay, but every time it is 146 only, right? Okay, so we can just store this thing into predicted. All right. So now we have the first word that we had given is 6. Okay. Next word predicted is 146. Okay. We are every time giving 6 over here. We are every time giving 6. So every time it is predicting what? 146. Okay. So what should we do? We can just build a logic, right? Which can, for the first time when we had given 6, 146 is predicted. Second time my model should get 6 and 146 together. So next value can be predicted. Okay. Next time these should be given together. So next value can be predicted. Right. So that kind of logic we have to build over here, isn't it? So for that, what should we do? Okay. So here we can define. Now first find out that what is the word related with 146. First of all, I have to find out what is the word related with 146. Right. So how can we find it out? Let's see. First I'll do it over here, then I'll do it there. Right. So I have my tokenizer. Okay. This my tokenizer is having an attribute called word index. Okay. This is representing the numeric value of each word. All right. I have to find out the word for 146. Right. So what can we do here? We will just we'll just convert this thing, use over here a method called items. Okay. So when we will just use items over here, so it will create a list of, okay, list in which you have a pair of what? Pair of key and value. It is key and value, key and value, key and value. Right. Now we will run a loop for you can say I should use over here what? Word comma id in. Okay, so this here, this is what giving me the dictionary. Okay, when I run it, I got the dictionary. Now that dictionary converted into a list of key value pair by using dot items. Now I'm running a loop which can access the word, okay, into one variable and id into second variable. Okay, word into one variable and id into second variable. Then again word into one variable and id into second variable. This is what we'll do. Right. So let's say over here, comma, print word comma ID. All right. So once we have this thing, I can do what? I can compare the ID. Right. So if ID double equals to 146, okay, then print that particular word. Okay. So it identified the word is never. Okay, so it is only printing when it is 146, right? So this is what we have to do here. All right. That means after we got this thing, this is giving me what? 146. So I'll write a logic. Let me just copy this thing and paste it over here. Okay. So I'll say that here for this thing, right? This is not required. If ID double equals to what? The predicted, okay, whatever the value that is predicted. Okay, like this. Okay, then print that particular word. So obviously it will print what? It will print never, but it will print never for so many times. Right. Now what we do, we will just add this thing into the input word. Okay, that means here I'll define a particular variable called output text. Right. I have to write a logic which can do what? Which can, add this particular word that is never into the existing word which is India. Okay. So how it can be done? Here when this condition happened, okay, when this condition happened, then I'll say that output text will be equals to, output text. That is a blank, right? So I'll say that when this condition happened, then this output text will be equals to the word. Okay. This output text will be simple equals to the word. Okay. And then and there we'll break the loop. We'll say that no, after this loop should not go further. Okay. And then when loop will break, okay, we'll take our input text, okay, here. And then again we'll do what? We'll just take our input text, and this input text will be input text plus output text. Okay. So the process is very simple. See, first, this guy will give me the 146. Right. Now this loop will start. This loop will find out the word associated with 146. It will find out the word associated with 146. When it finds out the word associated with the 146, okay, that word we can combine over here into the input text. Right. Once it is done, thereafter again this loop will go for the next part. Right. So this loop will run for how many times? 7 times. Okay. So it's like first time it only get what? India. But next time it will get India never. Right. And next time it will get something else. Right. So at the end, when process will end, your input text will become the final result. Okay. If I just call the input text after 7 times, here I am getting India never. So it's like kind of a no space is there. I should add a space also over here. Okay. So India never wanted to be seen in one. So it's like, I can generate, let's say I ask it to predict 20 words. So India never wanted to be seen in one camp or the other, or to be seen as a junior strategic partner. So it's kind of a generating meaningful output, okay, based upon the text, right? So we have a simple language model which is using the existing text data, okay, to predict the next word, and it is giving me the meaningful output, right? So only we have to do what? Once the model is trained, we have to frame this kind of logic. Which logic is doing what? It is just taking your input text, okay, it is taking your input text first, right? Thereafter making the predictions, okay, like converting the input text into number. So if it is a number input, number will be the output. So we are finding out the number over here, then we are finding out the word associated with the number and adding it into the input text, right? And thereafter again feeding the input text over here, again tokenization, again number, again prediction, then again feeding it over here. So this process will go kind of again and again, and finally we will get the words that we want. All right, so this is a thing that we did. I'll share this file with you. Let's just have a look. Let me know if there is any question, and then we go for the next part. All right. So here we had seen how a language model works, right? But these kind of architectures are good if your data size is limited. Okay, like one page document, two-page document, it is quite good. Okay, but when you are working on a very large scale data, means big data, okay, huge amount of data, like the data that GPT is using, okay, or any large language model is using. In such case, these models are not that good enough, because after some time it will start forgetting. Okay, it will start kind of missing the information, because we are adding everything in a sequence, right? It is learning what sequentially. Okay, it is learning sequentially. So there are different units are there. Okay, and these sequence are trying to learn about the pattern of the words, how words are arranged. Okay, and based on that pattern it will predict the next word. Okay, now if my data size increases, it start forgetting the information. Okay, because there are a lot of problems will be there. It's kind of a after each word, like suppose if I have a huge data, then right now I have 599 possible words. Okay, but if I have a huge data, then after each word there can be 5,000 possible words. Okay, there can be 5 million possible words, right, after each word. So it just get confused, or it just start forgetting what happened in the past. Okay, if the sequence increase it just forget the things like what happened in the past. Okay, so this was not good for the very large scale data, right? So around 2017, okay, or 15, you can say, first time this model was introduced, okay, to work on the sequential data or to work on the language data. This model is called what? Transformer, right? And transformer is something we just whatever the challenge that we are facing nowadays, okay, because of AI, generative AI, all because of this guy. Okay, that is called transformer. Okay, this turns the story completely. Okay, earlier it was just the predictive kind of things we were working. Okay, generative was also we were working, but they were not that much smart enough. But transformer made the things very smart. Okay, whole generation process. Okay, whatever the generation process that we are using, whole generation process becomes very smart because of presence of transformer. All right, team. So we'll just go ahead from here in the next class. That is it for the day. Shall I close it for the day? All right. Thank you.